Hello everyone and welcome to the final video on attempt at topographical mapping. So in this video we will see how to create a topographical map from the data that we have collected. Okay. So our first step would be creating a lat-long grid. So what's a lat-long grid? It's a grid of latitude and longitude where we can plot the coordinates. So our first step would be to input the benchmark coordinates. Okay. So why we are taking benchmark coordinates first? Because we want to demarcate the region of interest, like the region where which we are going to map. Okay. So when we plot the benchmark points, we can understand that yes, our region is in between these points. Then we can plot our data points later on. Okay. So to do that, we'll input this benchmark points in Excel. So we'll first find the smallest value and the largest value of latitude and longitude each. Okay, so I'll put the smallest and largest values. Okay, and then we'll see the range. Okay, the range is nothing but the nearest multiple of 5 or 10 seconds. Okay, here because the region is very small, so we'll talk about only seconds. Okay, so since our latitude coordinates, I mean the smallest and largest value is 19 degree 27 minutes 7.8 seconds, and the largest value is 19 degree 27 minutes 13.3 seconds north. So the nearest multiple of 5 from both sides is taken for the seconds value. Then we'll get our range as 19 degrees 27 minutes 5 seconds north to 19 degrees 27 minutes 15 seconds north. So similarly for longitude, our range would be 73 degrees 17 minutes 45 seconds east to 73 degrees 17 minutes 60 seconds east, which is nothing but 73 degrees 18 minutes east. Okay, so we got our range. Okay, so this range would be the limits. Okay, the limits of the grid where wherein we can put our region. Okay, like the hill which you are talking about, we are talking about the hill. Okay, so the hill will perfectly fit into this range. Okay, so we'll talk about the scale because since you're talking about grid, since you're talking about graph, we need to talk about scale. Okay, so here for accurate plotting, I'll use the scale as 1 division is equal to 1 seconds. Okay, which is nothing but 1 centimeter in normal graph paper. So okay, so in normal graph paper, when we will plot in normal graph paper, 1 centimeter would be equal to 1 seconds. Okay, so this gives us that in the latitude side. Okay, the latitude side is usually kept on the x-axis and the longitude is usually kept on the y-axis. Okay, so the latitude axis will need around the latitude axis will need 10 divisions and the longitude axis will need 15 divisions. Okay, because the latitude axis, the smallest value in the range is 5 seconds and the largest value is 15 seconds, so it will need 10 divisions. And similarly we have 45 seconds to 60 seconds, so it needs 15 divisions in longitude axis. Okay, so I have taken this 1 centimeter graph template from net. Okay, so we need to trim the graph template according to the required divisions. Okay, so using paint tab I'll trim the graph. Okay, so I've taken this 10 by 15 graph. Okay, we'll mark the extreme values. Okay, extreme values are the range values that we have taken. Okay, it's 73 degrees 17 minutes 45 seconds east, but to 73 degrees 18 minutes east. Okay, for longitude it would be 20 19 degrees 27 minutes 5 seconds north to 19 degrees 27 minutes 15 seconds north. So I plotted I've drawn the actual grid on the A1 sheet. Okay, but here I have taken the scale as 2 centimeter because if we take a larger scale it would be very accurate to map. Okay, but the only mistake I have done on this grid is that I have taken very large range, okay, which is very nearest to the minutes. So our area would be very very small in this. So I realized this mistake very late, but since I made it, I would not waste that paper and my efforts, so I will just continue on this. Anyways, let's continue on our graph. Okay, so our second step is plotting the benchmark points. So it's very very similar to what we plot in a mathematical graph. So we just have to plot the points according to the coordinates, okay, and just like you should plot it very accurately, okay, should be very very accurate to the seconds, okay. So we'll plot the points and then we'll join the points using polygon. Okay, so I've plotted the points, I've joined using this polygon, so I got this shape. So this is how it looks on my actual grid, on my A1 grid. Okay, this is very similar to bullet shape. My region is very similar to bullet shape. Anyways, so our third step is data processing. So I've input this data in Excel. Okay, it's around 88 points. Okay, so first we'll divide those data into three parts. Okay, and then we have to sort the data according to the smallest value and largest value of the altitude. So I sorted the data according to the largest value and smallest value. So the next step is plotting the data points. So how we plotted the benchmark points, in the same manner we have to plot the data points. But only thing we have to take care is that the data points are in seconds decimals. Okay. So but in our grade we don't have second decimals. So what we will do, we'll round off to the nearest second and then we'll plot the points. Okay. So I'll plot it according to the altitude, so it is very easier for plotting. Okay. So I plotted 2 points in my A1 grid, and this is how it looks after 26 points, after 54 points, and then finally after all the 83 points. It's very congested, but if the grid is big, we can do it very easily. Okay. So let's not forget to mention the data points like in the index, like how it is represented. Okay. So this is how it looks in my digital graph. Okay. So our next step is to create the contour line. Okay. So we'll draw the contours. So how we are going to draw the contours? So let's see, we have total points 83. Okay. And the maximum value we are having is 107 meters above MSL. Okay, and the minimum value is 91 meters above MSL. So the difference is actually around 18. Okay, so how we'll choose the contour interval? So we need to have a proper contour map such that we can understand the exact topography. So let's suppose we take contour interval as 2. So if the contour interval was 5, then we would get only 3 to 4 contours, not 4, just 3. Okay, because interval is only 18. The difference is only 18. So we would only have 3 contours, which would be very, very, very less accurate to depict the hill. Okay. So if we take a contour interval as 2, we would get around 8 to 9 contours. Okay. We can cover that hill, I mean the region which we are mapping, using contour interval as 2, such that the accurate depiction is possible. Okay. So since it's a very small altitude region, CI of 2 is very, very useful. Okay, so hence we will keep this as our contour interval for the map. Since we are taking CIS2, we'll plot even digits. Okay, like for example 92, 94, 96. So that would be very, very easy. Okay, so we'll start with the contour plotting. I mean, not the plotting, drawing. So we'll start with 92 first. So what we have to do, we just have to create a polygon which connects all the points in the grid. Okay, and make sure that that polygon line touches the benchmark polygon on both sides. Okay, so like this we have created the contours, and we have to mention the values of each contour. Okay, so I'll mention this. Now this is 106, 106. Since this is digital graph, and for better understanding I use different colors, but usually in contour it is usually black. Okay, or sometimes it may be blue, but usually we have to draw contours in black only. Okay. Only for better understanding I have used different colors. So similarly I'll mark the values of each contour line. So it's 106, 104, 102, 100. Then we have 98, then 96, 94, and lastly 92. Okay. So this is how the contour map is there, and we'll not forget to mention the index. So this is my A1 sheet map. Okay. The difference is clearly visible. Okay. You can see the difference between the digital graph and the A1 sheet graph. It's mainly due to selection of scale. Okay. Let's continue to our part 6. So we have to create a topographic section, because without a topographic section, topographical survey is not considered complete. Okay. So we'll see how to create a topographical section step by step. So I just copy this image in PPT because it's difficult to work for section on paint. Okay. So we require three things: a plain paper, scale, and pencil. So this is the section line where we are going to draw the section A, B. So we'll place the paper along the section line first. Okay. Then we have to mark the points A, B, or XY in my A1 sheet. Okay. Using those marks, we'll draw one side on a plain paper, and then we'll mark the intervals on vertical axis. Okay. So I'll do that in my PPT. Now the next step is we have to mark the contour intersections on the plain paper, like where the contours are meeting the section line. Okay, I'll just mark them. So we'll select all and group all. So using the same paper, mark the contour points. and then render the contour points on the graph, I mean the horizontal axis. So after rendering on the horizontal axis, we have to mark the points, okay, and then we'll create a polygon. Okay, so yeah, this is a polygon. So this is the section of the hill. So I've drawn this freehand curve on my graph, and we'll fill the curve to give out the shape. Okay, so this is how a section of top contour map is drawn. So this is on my A1 sheet. So using the same method, we'll create a section along XY, and that is the other side, which is perpendicular to the AB section line. The section of XY is small but very detailed, and it's very different from my A1 sheet because the line was, I mean, I took the line on the other side. Okay, so next step is creating the north sign and the index. So using the latitude and longitude, we'll align the north. So it is actually in the downmost right hand corner. So I'll just flip the map. Okay, so that the north is on the topmost left hand corner. Okay, so this is the final result after all doing all this work. Okay, so this is how my topographical survey map looks like on my A1 sheet. Okay, so and thank you very much for watching this video, and we'll come back with some new topic.